Welcome to episode 17 of my calculus series. Today, we're diving into the substitution rule for indefinite integrals. But before we get into it, if you're enjoying these episodes, a like, follow on TikTok, or subscribe on YouTube would really help me keep making more lessons like this. Alright, let's get started. What is the substitution rule? The substitution rule helps simplify integrals by reversing the chain rule. We let u equal g of x. Then the derivative of u with respect to x is g prime of x, or du equals g prime of x dx. Substitution rule formula. If u equals g of x, then the integral of f of g of x times g prime of x dx equals the integral of f of u du. Always rewrite the entire integrand and differential in terms of u before integrating. When to use substitution? Use substitution when you see a function and its derivative inside the integrand. The integral looks complicated but might simplify with a variable change. You can easily isolate du from the expression. Common mistakes to avoid: forgetting to change dx to du, not switching back to x after integrating in terms of u, choosing the wrong substitution. Examples. Example 1. Evaluate the integral of 2x times quantity x squared plus 1 to the 5th power dx. Let u equal x squared plus 1, so du equals 2x dx. Now the integral becomes u to the 5th du, which is u to the 6th over 6, plus c. Back substitute to get quantity x squared plus 1 to the 6th over 6, plus c. Example 2. Evaluate the integral of cosine of 3x dx. Let u equal 3x, so du equals 3 dx, or dx equals 1/3 du. Now the integral becomes 1/3 times the integral of cosine u du, which equals 1/3 sine u plus c, or 1/3 sine of 3x plus c. Example 3. Evaluate the integral of x times cosine of x squared dx. Let u equal x squared, so du equals 2x dx, or 1/2 du equals x dx. Now the integral becomes 1/2 the integral of cosine u du, which equals 1/2 sine u plus c, or 1/2 sine of x squared plus c. Example 4. Evaluate the integral of x over x squared plus 1 dx. Let u equal x squared plus 1, so du equals 2x dx, or 1/2 du equals x dx. Now the integral becomes 1/2 the integral of 1 over u du, which equals 1/2 natural log of the absolute value of u plus c, or 1/2 natural log of the absolute value of x squared plus 1 plus c. Example 5. Evaluate the integral of e to the 5x dx. Let u equal 5x, so du equals 5 dx, or dx equals 1/5 du. Now the integral becomes 1/5 the integral of e to the u du, which equals 1/5 e to the u plus c, or 1/5 e to the 5x plus c. Example 6. Evaluate the integral of 1 over the square root of 1 minus 4x squared dx. Let u equal 2x, so du equals 2 dx, or 1/2 du equals dx. Now the integral becomes 1/2 times the integral of 1 over square root of 1 minus u squared du, which is 1/2 inverse sine of u plus c, or 1/2 inverse sine of 2x plus c. Example 7. Evaluate the integral of 2x over x squared plus 4 dx. Let u equal x squared plus 4, so du equals 2x dx. Now the integral becomes the integral of 1 over u du, which is natural log of absolute value of u plus c, or natural log of absolute value of x squared plus 4 plus c. Example 8. Evaluate the integral of 6x plus 2 over 3x squared plus 2x plus 7 dx. Let u equal 3x squared plus 2x plus 7, so du equals 6x plus 2 dx. Now the integral becomes the integral of 1 over u du, which is natural log of absolute value of u plus c, or natural log of absolute value of 3x squared plus 2x plus 7 plus c. Recap. Substitution simplifies complicated integrals. It's like reversing the chain rule. Always make sure everything, including dx, is converted into du. And that wraps up today's episode. If this helped you out, don't forget to like, follow, or subscribe for more lessons. See you in the next one.